JSON Processing. This chapter describes the Java API for JSON Processing JSR 353. JSON is a data exchange format widely used in web services and other connected applications. JSR 353 provides an API to parse, transform, and query JSON data using the object model or the streaming model. The following topics are addressed here. Introduction to JSON processing in the Java EE platform using the object model API using the streaming API JSON and Java EE RESTful web services the JsonPmodel example application the JSON streaming example application further information about the Java API for JSON processing Introduction to JSON. JSON is a text-based data exchange format derived from JavaScript that is used in web services and other connected applications. The following sections provide an introduction to JSON syntax, an overview of JSON uses, and a description of the most common approaches to generate and parse JSON. JSON syntax. JSON defines only two data structures: objects and arrays. An object is a set of name-value pairs, and an array is a list of values. JSON defines 7 value types: string, number, object, array, true, false, and null. The following example shows JSON data for a sample object that contains name-value pairs. The value for the name phone numbers is an array whose elements are two objects: first name, Duke, last name. Java, age, 18, street address, 100 Internet Drive, city. Java, town, state. JA, postal code, 12,345. Phone numbers: mobile, 111, 111, 1111, home, 222, 222, 2222. JSON has the following syntax. Objects are enclosed in braces. Their name-value pairs are separated by a comma, and the name and value in a pair are separated by a colon. Names in an object are strings, whereas values may be of any of the 7 value types, including another object or an array. Arrays are enclosed in brackets and their values are separated by a comma. Each value in an array may be of a different type, including another array or an object. When objects and arrays contain other objects or arrays, the data has a tree-like structure. Uses of JSON. JSON is often used as a common format to serialize and deserialize data in applications that communicate with each other over the Internet. These applications are created using different programming languages and run in very different environments. JSON is suited to this scenario because it is an open standard, it is easy to read and write, and it is more compact than other representations. RESTful web services use JSON extensively as the format for the data inside requests and responses. The HTTP header used to indicate that the content of a request or response is JSON data is content type. Application. JSON representations are usually more compact than XML representations because JSON does not have closing tags. Unlike XML, JSON does not have a widely accepted schema for defining and validating the structure of JSON data. Generating and parsing JSON data. For generating and parsing JSON data, there are two programming models, which are similar to those used for XML documents. The object model creates a tree that represents the JSON data in memory. The tree can then be navigated, analyzed, or modified. This approach is the most flexible and allows for processing that requires access to the complete contents of the tree. However, it is often slower than the streaming model and requires more memory. The object model generates JSON output by navigating the entire tree at once. The streaming model uses an event-based parser that reads JSON data one element at a time. The parser generates events and stops for processing when an object or an array begins or ends, when it finds a key, or when it finds a value. Each element can be processed or discarded by the application code, and then the parser proceeds to the next event. This approach is adequate for local processing, in which the processing of an element does not require information from the rest of the data. The streaming model generates JSON output to a given stream by making a function call with one element at a time. There are many JSON generators and parsers available for different programming languages and environments. JSON processing in the Java EE platform describes the functionality provided by the Java API for JSON processing JSR 353. JSON processing in the Java EE platform. Java EE includes support for JSR 353, which provides an API to parse, transform, and query JSON data using the object model or the streaming model described in generating and parsing JSON data. The Java API for JSON processing contains the following packages. The JavaX JSON package contains a reader interface, a writer interface, and a model builder interface for the object model. This package also contains other utility classes and Java types for JSON elements. Table 19-1 lists the main classes and interfaces in this package. The JavaX JSON Stream package contains a parser interface and a generator interface for the streaming model. Table 19-2 lists the main classes and interfaces in this package. Table 19-1 main classes and interfaces in JavaX. JSON contains static methods to create instances of JSON parsers, builders, and generators. This class also contains methods to create parser, builder, and generator factory objects. JsonReader reads JSON data from a stream and creates an object model in memory. JsonObjectBuilder JsonArrayBuilder create an object model or an array model in memory by adding elements from application code. JsonWriter writes an object model from memory to a stream. JsonValue represents an element such as an object, an array, or a value in JSON data. JSON Structure represents an object or an array in JSON data. This interface is a subtype of JSON value. JSON Object JSON Array represent an object or an array in JSON data. These two interfaces are subtypes of JSON Structure. JSON String JSON Number represent data types for elements in JSON data. These two interfaces are subtypes of JSON Value. JsonException indicates that a problem occurred during JSON processing. Table 19-2 main classes and interfaces in JavaX. JSON Stream JSON Parser represents an event-based parser that can read JSON data from a stream or from an object model. JSON Generator writes JSON data to a stream one element at a time, using the Object Model API. This section describes 4 use cases of the Object Model API. Creating an object model from JSON data. Creating an object model from application code. Navigating an object model, and writing an object model to a stream. Creating an object model from JSON data. The following code demonstrates how to create an object model from JSON data in a text file. Import Java. IO. File reader. Import JavaX. JSON. Import JavaX. JsonReader. Import JavaX. JsOn Structure. JsonReader reader equal JSON. Create reader new file reader data. txt. JsOn Structure JsonSt equal reader. Read. The object reference JsonSt can be either of type JSON object or of type JSON array, depending on the contents of the file. JSON object and JSON array are subtypes of JSON structure. This reference represents the top of the tree and can be used to navigate the tree or to write it to a stream as JSON data. Creating an object model from application code. The following code demonstrates how to create an object model from application code. Import JavaX. JSON. Import JavaX. JSON object. JSON object model equal JSON. Create object builder. Add first name, Duke. Add last name, Java. Add age, 18. Add street address, 100 Internet Drive. Add city, Java Town. Add state, JA. Add postal code, 12,345. Add phone numbers, JSON. Create array builder. Add JSON. Create object builder. Add type, mobile. Add number, 111, 111, 1111. Add JSON. Create object builder. Add type, home. Add number, 222, 222, 2222. Build. The object reference model represents the top of the tree, which is created by nesting calls to the add methods and build by calling the build method. The JSON Object Builder class contains the following add methods. JSON Object Builder add string name, big decimal value JSON Object Builder add string name, big integer value JSON Object Builder add string name, boolean value. JSON Object Builder add string name, double value JSON Object Builder add string name, int value JSON Object Builder add string name, JSON Array Builder JSON Object Builder add string name, JSON Object Builder JSON Object Builder add string name, JSON value JSON Object Builder add string name, long value JSON Object Builder add string name, string value JSON Object Builder add null string name. The JSON Array Builder class contains similar add methods that do not have a name key parameter. You can nest arrays into objects by passing a new JSON Array Builder object or a new JSON Object Builder object to the corresponding add method, as shown in this example. The resulting tree represents the JSON data from JSON Syntax. Navigating an object model. The following code demonstrates a simple approach to navigating an object model. Import JavaX. JSON. JSON value. Import JavaX. JSON. JSON object. Import JavaX. JSON. JSON array. Import JavaX. JSON. JSON number. Import JavaX. JSON. JSON string. Public static void navigate tree JSON value tree, string key of key. Equal null system. Out. Print key plus. Switch tree. Get value type case object, system. Out. Print on object. JSON object equal JSON object tree for string name. Object. Key set navigate tree object. Get name. Break. Case array, system. Out. Print on array. JSON array equal JSON array tree, for JSON value val. Array navigate tree val, null. Break. Case string, JSON string street equal JSON string tree, system. Out. Print on string plus st. Get string. Break. Case number. JSON number num equal JSON number tree, system. Out. Print on number plus num. To string. Break. Case true, case false, case null, system. Out. Print on tree. Get value type. To string. Break. The method navigate tree can be used with the models built in creating an object model from JSON data and creating an object model from application code as follows. Navigate tree model, null. The navigate tree method takes two arguments. A JSON element and a key. The key is used only to help print the key value pairs inside objects. Elements in a tree are represented by the JSON value type. If the element is an object or an array, a new call to this method is made for every element contained in the object or array. If the element is a value, it is printed to the standard output. The JSON value get value type method identifies the element as an object, an array, or a value. For objects, the JSON object keyset method returns a set of strings that contains the keys in the object, and the JSON object. getStringName method returns the value of the element whose key is name. For arrays, JsonArray implements the list. JsonValue interface. You can use enhanced for loops with a set string instance returned by JsonObject. Key set in with instances of JsonArray, as shown in this example. The navigate tree method for the model built in creating an object model from application code produces the following output: object key first name, string Duke key last name, string Java key age, number 18 key street address, string 100 internet DR key city, string Java town key state, string YA key postal code, string 12,345 key phone numbers, array object key type, string mobile key number, string 111, 111, 1111 object key type, string home key number, string 222, 222, 2222. Writing an object model to a stream. The object models created in creating an object model from JSON data and creating an object model from application code can be written to a stream using the JsonWriter class as follows: import Java IO string writer, import JAVAX JSON JsonWriter string writer stWriter equal new string writer JsonWriter equal JSON create writer stWriter JsonWriter write object model JsonWriter close string JSON data equal stWriter to string system out print on JSON data. The JSON create writer method takes an output stream as a parameter. The JsonWriter write object method writes the object to the stream. The JsonWriter close method closes the underlying output stream. The following example uses try with resources to close the JsonWriter automatically. String writer stWriter equal new string writer. Try JsonWriter equal JSON. Create writer stWriter JsonWriter. Write object model. String JSON data equal stWriter. To string system out print on JSON data. Using the streaming API. This section describes two use cases of a streaming API: reading JSON data using a parser, writing JSON data using a generator. Reading JSON data using a parser. The streaming API is the most efficient approach for parsing JSON text. The following code demonstrates how to create a JSON parser object and how to parse JSON data using events. Import JAVAX. JSON. Import JAVAX. JSON. Stream. JSON parser. Parser equal JSON. Create parser new string reader JSON data. While parser has next JSON parser. Event equal parser. Next. Switch event case start array, case end array, case start object, case end object, case value false, case value null, case value true, system out print on event to string break case key name system out print event to string plus parser get string plus break case value string case value number system out print on event to string plus parser get string break. This example consists of 3 steps. 1. Obtain a parser instance by calling the JSON create parser static method. 2. Iterate over the parser events with a JSON parser has next and the JSON parser next methods. 3. Perform local processing for each element. The example shows the 10 possible event types from the parser. The parser's next method advances it to the next event. For the event types key name, value string, and value number, you can obtain the content of the element by calling the method JSON parser. Get string. For value number events, You can also use the following methods. JSON Parser. Is integral number JSON Parser. Get in JSON Parser. Get long JSON Parser. Get big decimal. See the Java EA7 API reference for the JavaX. JSON Stream. JSON Parser interface for more information. The output of this example is the following. Start object key name first name, value string do key name last name, value string Java key name age, and array and object writing JSON data using a generator. The following code demonstrates how to write JSON data to a file using the streaming API. File writer equal new file writer test. txt. JSON generator gen equal JSON. Create generator writer. Gen, write start object. Write first name, Duke. Write last name, Java. Write age, 18. Write street address, 100 Internet Drive. Write city, Java town. Write state, JA. Write postal code, 12,345. Write start array phone numbers. Write start object. Write type, mobile. Write number, 111, 111, 1111. Write end. Write start object. Write type, home. Write number, 222, 222, 2222. Write end. Write end. Write end. Gen, close. This example obtains the JSON generator by calling the JSON create generator static method, which takes a writer or an output stream as a parameter. The example writes JSON data to the test txt file by nesting calls to the write start array, write start object, and write end methods. The JSON generator close method closes the underlying writer or output stream. JSON and Java EE RESTful Web Services. This section explains how the Java API for JSON processing is related to other Java EE packages that provide JSON support for RESTful Web Services. See Chapter 29, Building RESTful Web Services with JSRS, for more information on RESTful Web Services. Jersey, the reference implementation for JSRS JSR 311 included in Glassfish Server, provides support for binding JSON data from RESTful resource methods to Java objects using JAXB, as described in Using JSRS with JAXB in Chapter 31, JSRS, Advanced Topics and an Example. However, JSON support is not part of JSRS JSR 311 or JAXB JSR 222, so the procedure may not work for Java EE implementations other than Glassfish Server. The Java API for JSON processing JSR 353 does not explicitly support JSON binding in Java. A future JSON binding that is similar to JAXB for XML is under consideration for a future release of Java EE. You can still use the Java API for JSON processing with JSRS resource methods. For more information, see the sample code for JSON processing included with the Java EE7 SDK. The JsonPmodel example application. This section describes how to build and run the JsonPmodel example application. This example is a web application that demonstrates how to create an object model from form data, how to parse JSON data, and how to write JSON data using the Object Model API. The JsonPmodel example application is in the TUT install. Examples: Web, JSONP, JsonPmodel directory. Components of the JsonPmodel example application. The JsonPmodel example application contains the following files: 3 Java server faces pages. The index. XHTML page contains a form to collect information, the model created. XHTML page contains a text area that displays JSON data. The Parsing. XHTML page contains a table that shows the elements of the object model. The object model bean. Java managed bean, which is a session scope managed bean that stores the data from the form and directs the navigation between the facelets pages. This file also contains code that uses the JsonObjectModel API, the code used in Object Model Bean. Java to create an object model from the data in the form is similar to the example in creating an object model from application code. The code to write JSON output from the model is similar to the example in writing an object model to a stream. The code to navigate the object model tree is similar to the example in navigating an object model. Running the JsonPmodel example application. This section describes how to run the JsonPmodel example application using NetBeans IDE and from the command line. To run the JsonPmodel example application using NetBeans IDE. 1. Make sure that Glassfish server has been started. See starting and stopping Glassfish server. 2. From the file menu, choose Open Project. 3. In the Open Project dialog box, navigate to tut install. Examples. Web. JSONP. 4. Select the JsonPmodel folder. 5. Click Open Project. 6. In the Projects tab, right-click the JsonPmodel project and select Run. This command builds and packages the application into a WAR file JsonPmodel. WAR located in the target directory, deploys it to the server, and opens a web browser window with the following URL, http localhost 8080 JsonPmodel 7. Edit the data on a page and click Create a JSON object to submit the form. The following page shows the JSON object that contains the data from the form. 8. Click Parse JSON. The following page contains a table that lists the nodes of the object model tree. To run the JsonPmodel example application using Maven. 1. Make sure that Glassfish server has been started. See starting and stopping Glassfish server. 2. In a terminal window, go to tut install. Examples. Web. JSONP. JsonPmodel 3. Enter the following command to deploy the application, mvn install. 4. Open a web browser window and enter the following address, http localhost 8080 JsonPmodel. 5. Edit the data on the page and click Create a JSON object to submit the form. The following page shows the JSON object that contains the data from the form. 6. Click Parse JSON. The following page contains a table that lists the nodes of the object model tree. This in streaming example application. This section describes how to build and run this in streaming example application. This example is a web application that demonstrates how to create JSON data from form data, how to parse JSON data, and how to write JSON output using the streaming API. This in streaming example application is in the tut install. Examples. Web. JSONP. JSON streaming directory. Components of the JSON streaming example application. The JSON streaming example application contains the following files. 3 Java server faces pages. The index. XHTML page contains a form to collect information. The fill written. XHTML page contains a text area that displays JSON data. The parsed. XHTML page contains a table that lists the events from the parser. The streaming bean. Java managed bean, a session scope managed bean that stores the data from the form and directs the navigation between the facelets pages. This file also contains code that uses the JSON streaming API. The code used in streaming bean. Java to write JSON data to a file is similar to the example in writing JSON data using a generator. The code to parse JSON data from a file is similar to the example in writing JSON data using a parser. Running the JSON streaming example application. This section describes how to run the JSON streaming example application using NetBeans IDE and from the command line. To run the JSON streaming example application using NetBeans IDE. 1. Make sure that Glassfish server has been started. See starting and stopping Glassfish server. 2. From the file menu, choose Open Project. 3. In the Open Project dialog box, navigate to tut install. Examples. Web. JSONP. 4. Select the JSON streaming folder. 5. Click Open Project. 6. In the Projects tab, right-click the JSON Streaming project and select Run. This command builds and packages the application into a WAR file JSON Streaming. WAR located in the target directory, deploys it to the server, and opens a web browser window with the following URL, http localhost 8080 JSON Streaming. 7. Edit the data on the page and click Write a JSON object to a file to submit the form and write a JSON object to a text file. The following page shows the contents of the text file. 8. Click Parse JSON from File. The following page contains a table that lists the parser events for the JSON data in the text file. To run the JSON Streaming example application using Maven. 1. Make sure that Glassfish server has been started. See Starting and Stopping Glassfish server. 2. In a terminal window, go to tut install. Examples. Web. JsonP. JSON Streaming. 3. Enter the following command to deploy the application. mvn install. 4. Open a web browser window and enter the following URL, http localhost 8080 JSON Streaming. 5. Edit the data on the page and click Write a JSON object to a file to submit the form and write a JSON object to a text file. The following page shows the contents of the text file. 6. Click Parse JSON from File. The following page contains a table that lists the parser events for the JSON data in the text file. Further information about the Java API for JSON processing. For more information on JSON processing in Java EE, see the Java API for JSON processing specification, http jcp.org. N. JSR. Detail. id = 350.